So let's have a small recap whatever we have done in the last class. First, we have done with respect to what are the different types of variables we are having. We have seen the different types of variables. Okay, variables. And in that, we have seen for continuous variables, discrete, and time series. Right? Majorly, any particular variables will be divided into three parts, that is continuous and discrete and time series, where discrete and continuous are with respect to cross-sectional data and time series data. Right? First, we have observed the variables. Second, we have understand what is meant by population and what is meant by sample. Sample is nothing but part of the population, where population is entire data, is called as population. Next, we have understand with respect to, we are going to work on the real time on the sample data. The reason behind of sample data is it is highly impossible to get the entire population data on time. So it will take so much of time, or it will take with respect to more costly. So that is the reason we are going with the sample data. So why in the interview they are going to ask you what type of analysis you are going to do, population analysis or sample analysis. If you are having the population data, no need to do the inference statistics, no need to do anything. We can say what are the values. For example, here in this class, 180 students are there. If I get all the students are giving their ratings, and if I calculate the rating and what is the average rating, and I have got as 4.75, something like this. Okay. Now, directly, whether I'm a good trainer or a bad trainer, we can conclude easily. But assume that I have got only 30 students has given me the rating, and they have given me average rating of 4.85, something like this. Sample mean. This is a sample mean of 30. Now, based on this, we have to conclude whether other students are also feeling in the same way or not, that we have to conclude. Here, we have to apply the inference statistics, or with respect to predictions, estimations, all these things will be done based on the sample. If you are having directly the population data, no need to estimate or nothing. Directly simple values only. But whereas in real life, you are not able to get the population data. Next, we have seen the different types of statistics, that is both descriptive and inferential. Descriptive means just describing the data. Inferential means inferencing the data. Inferencing means estimating the data. You are estimating the data based on the sample data, right? Now, next one we have seen with respect to in the descriptive statistics. Okay. So once we complete the descriptive statistics, we'll move on to the inferential. So first we are starting with respect to the descriptive statistics. In that descriptive statistics, we have seen the first one called as measures of central tendency. In the measures of central tendency, we have seen with respect to what is meant by mean. Mean is nothing but sum of the data points divided by number of data points, which are given by the symbol. Sum is given always by symbol like this. Total number of data points are given with respect to n like this. If it is a population mean, then it is sum divided by caps lock n. If it is a sample mean, then it is sigma divided by small n. And it is represented by x bar, and population mean was represented by mu. This is the first one, that is mean. Second one is with respect to called as median. Median, where we are having with respect to center position value. Center value with respect to position. This word is more important. Center position value. If you want to identify the center position value, first you have to make them in the order way, either ascending order or descending order. Choice is yours. In that center position, you are going to identify. Right? The center position value is called as median, and mode is nothing but most repeated value. Whichever is repeated, and out of repetition, which was particularly repeated more number of times, that is the one is called as mode. Most repeated value. Right? So this is called as measures of central tendency. Next, we have discussed about the measures of dispersion or measures of spread. It is also called as spread, how the data has been spread. That is range, which is nothing but maximum minus minimum value. Next, we have seen the variance, how much it has been deviated from the mean. Variance means deviation from the mean. Deviation from the mean, right? How much it has been deviated. Overall data, how much? Overall data, how much overall data deviated from the mean is by variance. If the variance is very high, means deviation is very high. If the overall data having with respect to variance of low, means deviation is low. Now here the variance was given the formula by population. For the population, variance is given by sigma square, where sigma of x minus mu whole square divided by caps lock n, and standard deviation was given by square root of this one, that is x minus mu whole square divided by n. This is the standard deviation. This is the variance and standard deviation. This is population variance and this is population standard deviation. Similarly, sample variance is given by s square is equal to sigma of x minus x bar whole square divided by small n minus 1. And sample standard deviation you have taken by using s is equal to square root of this one, that is x minus x bar whole square divided by n minus 1. This is the standard deviation. Standard means why we are going with the standard. Why? What is meant by deviation first? What is meant by deviation means how much it is deviated from the mean is called as deviation. Within that standard means it is going to give the standard value. Standard value in terms of units also getting back to the same position, and at the same time all the values are not getting nullified because you are going to take the square of them. If you don't apply the square means automatically it will be nullified. All the positives and negatives will be nullified and you will get the output as 0, means no deviation will be there. Right? Because what is the sample variance, sample mean? They are not going to ask you the formulas with respect to. They will ask you the question, in the sample why we are considering n minus 1. That is the interview question. We are going to say the answer as it is a Bessel correction, where it is going to apply the Bessel correction, and using the Bessel correction every time one will be left out. Right? Can we get it back? Do you remember everything? How do you know? How do you remember everything? What? Step by step alana చెప్పి అలవాటు అయిపోయి experience. Right? Now the thing is that sample variance and sample standard deviation. Now we are having with respect to a sample of with respect to x bar and sample standard deviation of s, population mean of mu and sigma, population standard deviation. These are called as sample statistic. There. Except that red one, you do anything. Done? Okay. Now, with respect to the statistics, samples will be given as the sample statistic and populations are called as population parameters. Right? Now, the next one is with respect to what does this standard deviation tell you? So now what is the use of standard deviation? This is the interview question. This is the interview question. They will not ask you in the interview what is the standard deviation formula. They'll ask, okay, you're applying the formula and you have got some value. What standard deviation will tell you? How much it is deviated from the mean. If the standard deviation is low, means what is the meaning? Deviation from the mean is low. If the standard deviation is very high, means deviation from the mean is very high. That is nothing but how much close the values in the data set are close to the mean. Standard deviation says that how much the values are close in the data set close to the mean. So if the small standard deviation is there, means all the data points will be close to each other. If large standard deviation is there, means data points will be distributed too far away to each other. Right? In this case, we are going to have the large standard deviation. In this case, it is a small standard deviation. All the points will be close to each other and that too close to the mean. They are close to the mean. Right? Is that clear? The importance of standard deviation. Next one we are having is called as coefficient of variation. Coefficient of variation is nothing but ratio of standard deviation to the mean. That is sigma by mu. So just you are going to calculate for any particular data, whatever the mean value and whatever the standard deviation, just sigma by mu is nothing but quotient of variation. Next one is measure of shape. The third one is measure of shape, where we are having with respect to skewness. The shape is whether it is symmetrical or non-symmetrical. Okay. So it is also applicable for continuous data. The range will not be applicable for the discrete variable. The range is not, standard deviation variance is not applicable for the discrete variable. So now whatever the mean is there, mean is applicable for the continuous variable. For continuous variable, you are applying the mean. Median, you can apply for the continuous variable. For the discrete variable, you can't apply, because discrete variable, you can't bring them in the order first. You can't bring them in the order. So if there is no proper order, then you can't identify the median value. If there is an order miss, median you can identify. But generally categorical data miss nominal data will consider as nominal data. For ordinal data, there is an order. For nominal data, there is no order. So if there is no order miss at that, in that position, you can't calculate the median, right? For example, let us take genders or hair color or colors, any colors, blue color, black color, red color, you are having like this. There is a column called as color. Now for this color, what is the median value? First you have to place them in the order. How you can place them in the order? So you can't place them in the order. That alphabetical order is possible, but generally what is the order means there is no order for them. So if there is no order, then you can't apply the median on that. You can't go with respect to black plus blue divided by 2. You can't do this one also. Average of black and blue also you can't do, right? So you can't apply the mean or median on the discrete variable. Whereas coming to the mode, you are going to apply this one on the discrete variable. This will be applied on the discrete variable. Mode means most repeated value. Even for the continuous also, you can apply the mode. Next, coming to the range, you can apply only on the continuous data. Black minus blue, you can't do that minus or anything. With respect to variance, there is no mean only means how variance will be possible for the discrete variable. So this is also not possible. Only for the continuous variable mean variance is possible. And next one is standard deviation. This one also continuous variable only. For continuous variable only it is possible. And next, quotient of variation, that is also possible for continuous variable. For discrete variable, none of them is possible except mode. Except mode, nothing is possible for the discrete variable, right? Now coming to the next one called as shape. Now for continuous variable, we know already the histogram. I have told you what is meant by histogram. In the last class, I have told you histogram. Now for the histogram, whatever we are having, now from the center, if you draw a center line like this, it is symmetrical or not. If both of them are symmetrical, this is called as symmetrical distribution. If both of them are not symmetrical, it is called as non-symmetrical distribution. That's it. From the center line, if both the shape, left side and right side, the shape are same miss, it is called as symmetrical distribution. If both of them are not same miss, it is called as non-symmetrical, which is also called as skewed distribution. Non-symmetrical distribution is also called as skewed distribution. Symmetrical distribution is also called as normal distribution. Symmetrical distribution. Distribution means entire data, right? Entire data was, you are writing the entire data, the distribution of the data. The entire data distribution you are going to take as like this. For example, earlier, I have shown you in the last class with an example like this. So this is the data. Actually, we have got the data like this. Now the same data we are converting to a histogram like this. This is the data. This data I am writing the histogram like this. Now this histogram I am going to check from the center value, that is from the mean value. For this entire data, what is the mean? Mean is nothing but this one only, obviously. So here 90 and 140 is there. Center value will be with respect to this is the mean. From the mean, left side and right side both are same or not. The shape are same. It is called as normal distribution. If it is not same, then it is called as unsymmetrical distribution, which is also called as skewed distribution. Example. Let me write like this. From I have kept an exam. In that exam from 0 to 10. The students has got with respect to how many students are there means one student is there from 0 to 10. From 10 to 20, 2 students are there. From 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, and 90 to 100. Okay, this one also 1, this one also 2, 3, this one 3, 4, 4. 5, 5. Okay. So this, if I draw like a histogram from 0 to 10, 1 student, from 1 to this one, 2 students, 2 to 3, 3 to 4, 4 to 5, and 5 one more, and 4, 3, 2, 1. If I draw a center line like this, now it is symmetrical distribution, which is a normal distribution. Now, if you are having a total, how many students are there? 10, 20, 30. 30 students are there, out of which 30, this is total 30 students. Total list is 30 students, out of which 0 to 10, one student only is there. Who has got with 0 to 10? Take one example. Choice is yours. 30 values you want. From 0 to 10, take one value, 9.5. Randomly choose some numbers. Okay, at the end, the distribution will be the same only, right? Now assume if you are having the same example in the data, whatever the exam is there, and I'm having with respect to the students here 0. This student is 0, 1 student, 1 student, 1 student, 1 student, 1 student, and 1, 2, 3, 4, 5. Here I have got 20 students and 3 students and 2 students. Again, total 30. Now, this is not symmetrical. With respect to from the center value, left side and right side both are not same. Left side only 3 students are there. Right side almost 27 students are there. 27 students are there. Both are not same. If both are not same, it is called as non-symmetrical distribution, which is also called as skewed distribution. Now this skewed will be with respect to either left skewed or right skewed. You are going to have the left skewed and right skewed. Left skewed means if more number of values on the left side and right side less number of values are there, means it is called as right skewed. Okay. So if it is a symmetrical distribution, the same example whatever I have told you, 1, 2, 3, 4. Let me change the color. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Now in this case, it is a symmetrical distribution. Okay. So symmetrical distribution you are having like this. Now, whereas for the symmetrical distribution, which is also called as normal distribution, where the mean and median will be the same. Okay, almost the mean and median will be the close. The values will be close to each other. The mean and median will be almost same. Now, whereas skewness refers to the asymmetry. Asymmetry means non-symmetrical distribution. Now, if you are having less number of values on the left side, means it is called as left skewed. If you are having less number of values on the right side, means it is right skewed. Skewed means less. Decreased. It has decreased like this. So right side very number of less values are there, means right skewed. If left side number of values are low, means left skewed. Right? That is right skewed and left skewed. So here any value, any distribution, if you are having less number of values on the left side, means it is called as left skewed. So more number of values are here only, means obviously the median also should be here. Example, earlier example, whatever I have drawn here is there. So whatever the example I'm drawing here, just let me draw one more time the same example. So almost everyone understands the symmetrical distribution. Now let us see this one. From 0 to 10, this is 0 to 10, no value. From 10 to 20 also no value. From 20 to 30, 1 value. 30 to 40, 1 value. 40 to 50, 1 value. 1, 1, 1. And after that, 50 to 60 also 1 value. 60 to 70 also 1 value. And suddenly you have got with respect to 20. And this one with respect to 3 values. And next one is 2 values. Okay, 80, 90 and 100. Now you are having the data like this, which is nothing but left side, very less number of values are there, skewed. Now, for example, out of 30, where the median value will be located? In which, what is the meant by median? What is the location of the median? That is 30 plus 1 divided by 2, which is nothing but 15.5 between the 15 and 16. Where the 15th value will be there? 1, 2, 3, 4, 5 values are completed. 15th value will be in this bar only, right? Obviously. So here only the median is there. In this bar only the median value is located. Your median value is in this bar, whereas mean value will be exactly in the center. It will not change. Mean cannot be changed. In the center only. It will. You have to draw the mean here only. So now in this case, now median value, mean is less than the median. So mean is less than the median. Mean value will be here, which is approximately 50 to 60. Average of 100 means let us take 50, right? So mean value will be in the center position, whereas median will be in this bar. So for left side, left skewed distribution, the mean is less than the median. And for the right skewed distribution, automatically the median will be less than the mean. Mean will be always in the center position. Median will change based on the whatever the number of values are there. Right? Mean will be always in the center point. This is always in the center. It will not change. Is that clear, guys? This is one of the question in the exam, NASCOM exam or TCS exam. All these exams will have this kind of questions. For left skewed distribution, which of the following is true? Option A, mean is equal to median. Option B, mean is less than median. Option C, mean is greater than median. And option D is none of the above. Which one is true? So immediately you have to draw the left skewed distribution. Draw the left skewed and like this. If you draw means left skewed, you will get. Obviously, median will be more number of values in which bar is that one only the median. So you draw the median here. Mean will be in the center position. Okay, mean is less than median. Tick that one. No need to remember also. No need to by heart also. First, draw the left skewed distribution. Randomly, you take some values and draw the left skewed on the spot. Sir, can you explain with a real example some values? Okay, let us take some values. Tell me, choice is yours. You only tell me some certain values. Like I'm taking you 14, 24, 30, 28, 32, 40, 45, 46, 49, and 76, 78, 77, 79, 84, 72, 71, 72, 74, and 88, something like this I have written. Okay. So now first 0 to 10. How many 0 to 10 are there? 0. So no need to draw. From 10 to 20, one value. From 20 to 30, how many values? Again, one value. Right side part should not, oh, this one also. So two values, right? So 30 to 40, 1, 2, two values. So two values. 40 to 50, 1, 2, 3, 4. 4 values. 50 to 60, no values there, empty. 60 to 70, empty. Again, 70 to 80, 1, 2, 3, 4, 5, 6, 7, 8. 8 values. From 80 to 90, 2 values. Okay, now can you please calculate the mean value of this? All the values if you add and if you can calculate the mean, obviously the mean will be here only in this particular location. Between 50 to 60 only the value will be there. And now if you calculate the median, total how many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 6, 9, 12, 15, 18, 19. 19 values are there. What is the median value? 10th position value. 19 plus 1 divided by 2, which is 10. 10th position. 10th position means this is already 9. In this, what is the least value? This one. This is the median value. For this data set, this is the median value. Average value will be between 50 to 60 and median value will be the 71. Now, 50 to 60 is low or 71 is low? So mean is lower than the median since it is a left skewed distribution. If you want, you can try also. For these values, you can try also. Randomly I have written. The numbers I have written randomly. I know only one thing. When compared to left side, right side should be more values should be there. I know only this one. In my mind, only that one is there. I'm not focusing on the values. If left side, if 40 values are there, means right side 90 values I used to write. So that left side distribution I want means left side less value should be there, right? Instantly I have created one example and I have written myself and I have checked whether the mean and median, whichever is low. Now, sir, how to calculate this many number of values, sir? Can you go with still simple example? 1, 1, 1, 2, 2, 3, 3, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. Okay, done. Now, 1 to 2, 1, 2 values, 2 to 2, 2 values, 2 values, 3, 6, 8. Left skew distribution only. Left side less values are there, left skew distribution. Now, can you calculate the average value easily? Because 8 into 4, 32, 32 plus 6, 38, 38 plus 4, 42, 42 plus 2, 44, 44 divided by 14 values, which is nothing but approximately 3.1. So 3.1 is the mean value. What is the median value? Mean is less than the median. Once again. Simple example, calculation. With calculation I have done completely. Is that clear? Sorry. Someone asked some question. Yes. Formula is n plus 1 by 2 is where n is the number of data points. Yes. N plus 1 by 2 is the formula for the center position. For example, this here total how many values are there? Total how many values are there? 14 values are there. In this, what is the center position? Can you tell me? Huh? Center position. Which 4 is the center position? This one is the center position. Nah? That how to get that one? 14 plus 1 divided by 2. That is nothing but 7.5 means average of 7 and 8 position. Average of 7 and 8 position is the center position value. They're also the same. Just you take the data sets. You give randomly some values. You give some values. There I have taken some randomly some values and I have calculated. That's it. Is that clear? So here assume that this number of values 0 to 10, 10 to 20, 20 to 30, 30 to 40, 50, 60, 70, 80. Okay. From 0 to 10, you are having only take any two numbers. Let me draw with the 2 or 3. Let me take 3. Okay. This is 2. This is 1. This is 4, 5. This is with respect to 7. This with respect to 9. This is 16. Okay. Tell me total how many values are there? How many values are there? 3 plus 9, 12, 12 plus 16, 28, 28 plus 7, 35, 35 plus 5, 40, 44, 46, 47. So total is 47. 47 values are there. Can you select on your own choice from 0 to 10? Tell me any 3 numbers. From 0 to 10, any 3 numbers randomly. Repeat also not a problem. Anything. From 10 to 20, tell me any 9 numbers. You take some 11 numbers. Now from 20 to 30, 16 numbers. From 30 to 47 numbers. You take all the values, total 47 values you take. Now in this 47 values, out of 47, what is the center position value? What is that one? 24. Where the 24 will be there? 3 plus 9, 12. 12 plus 16, 28. Miss, where your median is there? Here only, na? Between 20 to 30 only your median is there, right? Got the point? You take any data set with randomly, you take some values. From 0 to 10, take 3 values in your notes, right? From 10 to 20, write 9 values. From 20 to 30, you write 16 values in your notes. And you only select what is the median value. You only calculate manually. That if you write the data set, for example, all the number of points, if you write manually, if you starting writing the manually every data point, now what it will do is, it will take time. Whereas now directly in the histogram, we can easily conclude the median and mean value based on the distribution of the data. Is that clear? You take some values, write in your notes the histogram. Whoever has doubt, those students, write in your notes this one. And take any 3 values from 0 to 10. Any 9 values from 10 to 20. Any 16 values from this one. And you only calculate for that 47 data points, what is the median value. You do the manual calculation. After that, you apply the histogram and you check. The median value will be between 20 to 30 only, because your requirement of 24th value will be here only. If you keep in the sequential order, automatically the 24th value should be in the less than 28 only. Na? It can't be more than 28, right? So obviously that value will be here only. If you calculate, randomly choose any values. If you calculate, the mean will be here only. Exactly the mean will be from 30 to 40 only. If you want, you can try. Okay. Any value, check any value. Any values from 0 to 10, take 3 values. Write the histogram in your notes and take the randomly after the class. And you do the calculation. You do the first mean value, you calculate the median value. Then you'll understand everything clearly. For this example, since you asked for this example, I'm saying. Clear? Next. So from this, we can conclude that for symmetrical distribution, the mean, median, mode will be the same. Right? For example, let us take like this. 1, 1, 2, 2, 2, 4, 3, 3, 3, 3, 4, 4, 4, 4, 4, 5, 5, 5, 5, 6, 6, 6, 7, 7. Now, if I am drawing the histogram, 2, from 1 to 2, how many values are there? 2 values. From 2 to 3, 3 values. From 3 to 4, from 4 to 5, 5 values. 3 to 4, 4 to 5 miss. And from 5 to 6, from that. Next. Right? You are having this, now this is a symmetrical distribution or symmetrical distribution only. So you can clearly see that it is a symmetrical distribution. If you draw from center line left side and right side, you are having the same thing. Now for this, calculate the median value. Total how many values I have selected? 2, 5, 9, 14, 18, 21, 23. 23 values are there. 23 values, what is the center position value? 12th position. That is nothing but 5, 9, this one. This is the median value. This is the center position value. Right? Center position already is in the order now. This already is in the order. If it is not in the order, I have to make in the order. But already is in the order now. So this is the median value. For this, what is the mean? Mean is nothing but 2 plus 6 plus 12 plus 20 plus 20 plus 18 plus 14. So that is nothing but 8, 20, 60, 78, 92. 92 divided by total how many values? 23. So which is nothing but almost close to 4.2, approximately 4.2. So Mean and median both are same. Median is 4 and mean value is 4.2. Calculate for this data set, take the data set and you only calculate the mean and median. You only tell me how to calculate the mean and how to calculate the median, you know already. Tell me the mean value and median value for this. Since it is a symmetrical distribution, the mean and the median will be almost close to each other. Randomly I am choosing. Sir, how from 1 to 2 you are confused with 2 miss? Let us take this 1.2, this is 1.3. Now you will be happy now. 1.2, 2 values are there. This one. Right? Now tell me from 1 to 2 how many values are there? Now it is clear, right? From 1 to 2 only 2 values are there. Earlier we are having the confusion that exact number of 2 again. Now it is very clear, right? Data set is very clear. The same data, for the same data, this is the histogram. Now you calculate the mean value, median value. Mean value will be 4, median value will be 4.3. Mean value will be 4.46. It is going to be approximately 4.46. If you want, you can check after this. You do the calculation. Right? So just for the normal distribution, the mean and the median will be the same. Right? So for the normal distribution, the mean and median will be the same, whereas left skewed, the mean is going to be less than the median. For right skewed, the median will be greater than the median. Right? Now, now here we are having the next one called as kurtosis. The next one is called as kurtosis, where we are having the kurtosis with respect to earlier the skewness, whatever the skewness is there. Any histogram, you are having a histogram like this. A histogram you are going to represent by using a curve like this. This is called as curve. Okay, the same, instead of representing the same histogram, you can represent the entire histogram by using a curve like this. This curve is called as density curve, that we are going to see in the next. After this, I'll explain. Okay. So as of now, you have confused with respect to what is this kind of curves and all these things. Means don't worry about the curve. Curve I am going to explain in the further. Density curve. Right. Once we explain the probability, then you will understand the density curve easily. Now coming to the next one called as kurtosis. Whereas skewness tells us about the how the entire data was distributed like this with respect to the width. Now kurtosis tells with respect to the height. So if it is very small and with respect to the distance is small and the height is very large, high and thin. Thin means the distance, this one. Thin and large means it is called as leptokurtic. And if it is normal, a normal distribution, which is having a normal distribution, then it is called as meso. And if it is having with respect to bulginess, with respect to low height means, then it is called as with respect to platykurtic. Right? This is with respect to the kurtosis. The kurtosis and skewness tells the how the shape of the data is there. Both of them tells about the shape of the data. That is the reason both of them are called as measures of shape. Both comes under measures of shape. Right? Is that clear, guys? Now, the next one is called as percentile. Now here, one of the most important concept comes into picture, which is called as percentile. Most means most. Again, you can keep with respect to star marks. Okay. Percentile tells about how much percentage of data values that fall below to you. For example, you are saying that I am in the top 2 percentile. For example, cat rank. Cats generally will be in terms of percentile. For example, you have got 99 percentile. In the cat examination, you have got 99 percentile. What is the meaning of that? Out of how many have attended, within that 99% of the people are lower than you. 99% of the people are lower than you. That is the reason your score is 99 percentile. You have got with respect to 99.99 percentile. What is the meaning of that? 99.99% of the data is below to you. For example, you are having with respect to in the class, total 100 students are there. And 100 students has got with respect to 100 marks. Each student has got one mark. Assume that first student has got 1 mark, second student has got 2 marks, third student has got 3 marks, and fourth student has got the 4 marks. Assume that this is the data set. For a simple explanation, I'm saying. Okay. Now I'm having with respect to 100 students and their marks are there. Now you got with 99 marks. You assume that you are the student and you have got the 99 marks. And you are in the first student is 100 marks. You are in the second student, which is 99 marks. You are saying that I'm in the top 2 position. What is the meaning of this, miss? Remaining people are lesser than you. Top position you are saying. Or otherwise, if you say 99 percentile, in your class, what is your percentile, miss? 99, miss. What is the meaning of 99? 99 below to you, 99 numbers are there. Either equal to you or less than to you, including you also, including your number also, I'm saying. So the percentile tells how much percentage of data values that fall below to you. How much percentage of data values fall below to you gives you the percentile. Now you are having with respect to called as percentage and percentile. 2 things are there. Percentage and percentile. Don't confuse between these 2. For example, in your BTech exam, you have got with respect to 72 marks out of 100. What is your percentage, miss? 72 is the percentage. This is fixed. What is your percentile, miss? It depends upon others. How many of them are better than you? How many of them are worse than you? It depends on the others. Whereas percentage will depend only on you. Percentage is your own, irrespective of others. Whether others has got 90% or 200% or 300% or 100% or 40%, whatever it is, irrespective of them. Whereas percentile is comparison with respect to others in what position you are there. That is percentile. That is the difference between the percentage and percentile. Percentage is always fixed value. For example, out of 50 marks, assume that, okay, let me write like this. In a class, total 10 students are there. Take an example of 10 students. Okay. Student number 1. Let me, I think I'm having the data also. Just give me a minute. Total 15 students are there. And out of 50, they have got these are the scores. 15 students and out of 50, these are the marks. Now, first you are going to make them in an order. Okay. In this order you have made. Now, what is the percentage of this particular student? Percentage. He has got 43 out of 50. 43 divided by 50, which is 86%. Whereas percentile, 100 percentile. He is the topper and below to him, entire data is there below to him only. Including him, the below entire data is there. He is a 100 percentile student. Now, what about this one? Percentage. Tell me percentage. 15 divided by 50, which is 30%. That is percentage. What is the percentile? 0 percentile. Percentile indicates how many number of data points are below to him. None of them are there below to him. 0 are there. So he is a 0 percentile student. Is that clear? Percentage says that position. In what position you are there in the given data. Percentage says about the position and percentage says about the value. Once again. That is the difference between the percentile versus percentage. Clear, guys? So here, if you go with the center position, total how many are there? 15. What is the center position value? 8th position is the center. Which one? Here 8th position is, what is the 8th position? Right? So left side 7 students are there, right side 7 students are there. He is in the center position. Now this, what is the percentage of his? What is the percentage? He has got 35 out of 50, which is nothing but 70% he has got. That is percentage. 70% he has got in this, but that particular exam. Now what is his position? 50 percentile. 50% of the data is below to him. This is called as median. Median is also called as 50 percentile. 50 percentile and median both are same. 50 percentile or median both are same. Is that clear? So 50% of the data is below to him. Including him, 50% of the data will be there. Okay. So we are having with respect to the median, which is 50 percentile. Q1 means 25 percentile. 25 percentile is also called as quartile, not quarter, quartile. Okay, quartile. Quartile means Q1, which is nothing but tile. Tile means percentile. Percentile means 25%. 25 percentile. The 25 percentile is represented by Q1. Median, which is nothing but 50 percentile, which is also represented by Q2. 2 quarters, half, right? Whereas this one with respect to Q3 is nothing but 75 percentile, 3 quarters. Okay, 3/4 of the data. This is 1/4 of the data. This is 50% of the data. Here 75% of the data is below to him. If you observe, 75% of the data will be below to him. Then it is called as Q3. So Q1 is also called as 25 percentile. Q2 is also called as 50 percentile. Q3 is called as 75 percentile. What is meant by percentile means percentage of data points. 75 percentile means 75% of the data points are below to him. 50 percentile means 50% of the data points below to him. 25 percentile means 25% of the data below to him. Him means here the value. Below to this value. Is that clear? And which was represented by Q1, Q2 and Q3. And this is the minimum value. It is represented by minimum and this is called as the maximum. 100 percentile is also called as maximum value. This is called as 100 percentile. Maximum value is called as 100 percentile and minimum value is called as 0 percentile. Is that clear? So if you remember in the starting in the demo session, I told you that I am in the top 2 percentile in the Kaggle competition. Percentile. I have used the word of percentile in Kaggle. You have to use in the Kaggle every time percentile, because in the Kaggle, if someone is better than you, for example, you have uploaded your answers today and you have got a rank, certain rank. Tomorrow, one more person uploads the data and he's better than you, means automatically your percentile will be dropped. So here, whatever the competition I have taken, it is approximately 15,500 people has taken that competition. Within that, I am in the top with respect to 2 percentile. 2 percentile means which is nothing but 310. My rank is below to the 310. Then it is called as top 2 percentile. Percentile means I am top 2 means remaining 98% of the data is below to me. That is the meaning. In our resume, we have to mention the percentile, not with respect to the rank. If you mention out of 15,500 something like this, and you have mentioned with respect to, for example, here 310 is very high. Okay, very good rank. But assume that this competition was taken by 310 students only, your rank is 310. In the resume, you have mentioned 310 is the rank. Where is total number of students? Out of 310 also, your rank can be 310, right? So if you mention the rank, there will be no use. So you have to take with respect to how many people has attempted that one. Within that, what is your rank? That is with respect to percentile, right? So if someone adds suddenly, for example, tomorrow one more person is better than me and he has uploaded his one in the Kaggle, automatically he will get the better one and my percentile will be reduced. So if I'm in the, my rank is less than 155, I'm in the top 1 percentile. If my rank is within 310, top 2 percentile based on my rank. So here, if you open the Kaggle competition, of course, you are going to do in the later class. Okay. So if you open the data, some kind of this one, and where we are having any data set which is open, Kaggle competition, some competitions will be open for a set of time. Some competitions will be open for continuously. So whereas this competition is open for 24/7, 365 days. So anytime you can submit your answers and you can see your position in the leaderboard. If you come into the leaderboard, here you are having with respect to the values, 14,457 people has attempted. Here my rank is not there as of now because every 3 months once your past data will be erased. So what I'm going to do is I'm uploading my submission once again in front of you. So it is asking drag and drop. So let me drag where it is located. Okay. And I'm submitting my answers. So how to submit and how to do the answers that we'll see later. And here I'm going to open the leaderboard position. So in my leaderboard position, now you can see my rank. It is 238 out of 14,459. It is 238. This is my name. This is my photo. Okay. And how to attempt this one, we'll see later. This is casually, just whatever we have done in the class that I have saved. If you work miss, you can get in the top 1% easily. Okay, this generally while doing in the class projects we have done. Now what I want to say is here the rank of 238 you should not mention. You have to mention in the top 2 percentile. Means with respect to 2%, 14,457 into 0.02, which is nothing but 288. If your rank is less than 288 means you are always in the top 2 percentile. If your rank is below 144 means you are in the top 1 percentile. Right? So percentile says that how much percentage of people are lesser than you. Here I am saying the top 2 percentile means then below to me 98% of the people are there. That is the meaning of that. Is that clear, guys? Percentile. So whereas we are having with respect to the Q1, so Q1 gives with respect to quartile 1, which is 25 percentile of the data. Q2 means 50 percentile of the data. Q3 means 75% of the data. Any Q3 value is then miss, then that 75% of the data is below to that. That is the meaning of that. Right? Now, Q1, 25% of the below data is called as first percentile. 50% of the data, 75% of the data. Q1 is exactly called as 25 percentile. The meaning of that is 25% of the data is below to that. Right? Now, for this data set, how to calculate the percentiles, 50 percentile or quarter, all these things, how to calculate means, first we have to take in the order. In the order, first center value. So center of these two is nothing but 116 plus 121 divided by 2, 118.5. 118.5 is the Q2 value, which is nothing but median. Now, you are having this first part. This is the first part. This is the second part, second half. Within the first half, whatever the center value is there, that center value is called as 25 percentile value. Within the second half, whatever the center value is there, that value is called as Q3 value. So just I'm calculating in the same manner. That is 116 plus 121 divided by 2. Now I have got the Q2 value, that is 118.5, which is 50 percentile. 50% of the data is below to this value. You can see 50% of the data, that is out of 8, 4 data points are below to this. Now, 25 percentile, that is average of these two. Because out of first 4, center value. From 0 to 50, center value is 25. From 50 to 70, 50 to 100, center value is 75 only. If you take the average of this one, 75. So in this way, you can calculate the percentile. Okay, Q1, Q2, Q3. And we are not going to do any kind of manual calculation. None of the manual calculation we are going to do in the real life. All these manual calculations are useful only in the certification exam. In the certification exam, they are going to give the data and they will ask you what is the Q1 value, Q2 value, Q3 value. At the time, you have to do the calculation. Directly, I can show you this one by taking the called as array. I can convert this one as an array by taking a list, array of this list. And once we converted this one, array of A is equal to np dot percentile. np dot percentile of a comma 25 means I'll get directly the value of 115.5. This is the Python code. For this array, what is the 25 percentile value is 115.5, 111.5. I'll get directly answer. But this code is applicable in the real life. But in the certification, you can't apply the code now. In the certification, you have to do the manual. So that is the reason I'm explaining the manual calculation. But in real life, you don't need to do any kind of manual calculation. And that too, we are having shortcut also for this. The entire statistics we can get by using a single function called as df.describe. By using one single function, till now, from yesterday to today, whatever we are discussing, everything you can get in a single shot. All the values you will get in a single shot. That too for all the columns, not for a single column. For all the columns you are going to get by using a single function called as df.describe. This is the pandas code. But how it is calculating the backend? What is the backend code? Means that is the theoretical calculation what we are discussing. Is that clear, guys? Next one is called interquartile range. Interquartile range means Q3 minus Q1 is called as interquartile range. Okay, interquartile range, that is Q3 minus Q1. Right? This is called as interquartile range. Q3 minus Q1. Now, for the data set, we are calculating Q1, Q2, Q3, and don't confuse with the percentage with percentile. So I have written very clearly where this one is called as percentage. This is not called as percentile. Percentile. And next one is called as 5 numbers summary. One more time, star marks. Multiple star marks. Multiple means multiple. 100, 200 also you can keep. No problem. Such an important topic in entire statistics. This is 5 numbers summary. The 5 numbers you already know. One is called as minimum, first quartile, median, third quartile, and maximum. These 5 numbers are called as 5 numbers summary. Now using these 5 numbers, we are going to discuss about the distribution of the data. How the data will be distributed. So for example, this is the data set. Out of the data set, I have got with respect to Q1 value as 25. I calculated, and median value as center position is 33, and this one is 36. Q3 is this one. What is the minimum value? 10. What is the maximum value? 59. Now for the data, once we calculated the 5 values, forget about the data set. Once we got the 5 numbers, we don't need of the original data set. Now using these 5 numbers, you have to represent a plot called as Bose-Vickers plot. Very simple. Just on the x-axis, wherever the number 10 is there, let us assume this is 10. You keep a point like this, 1 point. And wherever the 25 is there on x-axis, keep 1 more point. And wherever the 33 is there, keep 1 more point. So I'm going to keep a point like this, or point or line. You can draw a line, simple 1 line. 5 lines you draw like this. And you connect this Q1, Q2, Q3 into one box. You connect them into one box. And you do the extension for remaining 2. This is called as Bose-Vickers plot. This is called as box. Center one is called as box, and this is called as whisker. So Bose-Vickers plot, which is also called as shortcut box plot. Okay. So using these 5 numbers, just you are going to represent the 5 numbers using a plot like this. 10, wherever the 23, 25 is there, 33, 36, and 59. Just you draw the box. The center one, whatever the Q1, Q2, Q3 is there, that you are representing by using a box, and the extensions you are representing by using the whiskers, which is called as Bose-Vickers plot, which is also called as box plot. If boxes are same, if the boxes are even, then it is called as symmetrical distribution. If the boxes are uneven, which box length is more? If the box length of left side is more, then it is called as left skewed distribution. If the box length of right is more, right skewed distribution. If both the boxes are same, second priority you have to give for the whiskers. If the boxes are same only, second priority for viscous. Out of viscous, if the right side whisker is more miss, right skewed. Left side whisker is more miss, left skewed. Boxes are same, viscous are both are same miss, then it is called as normal distribution. Right? So here I am drawing an example. Now for this, left skewed or right skewed? Left skewed. First priority only for the box. For example, box is like this. Okay. And you are having short whisker and long whisker like this. Now, again, it is left skewed. Again, you have only first priority box only. If boxes are same only, whisker. I have clearly told that boxes are same only, second priority for whiskers. If the boxes are uneven, first box only. If the boxes are same, whisker, then you have to see the whiskers. And if box and whiskers both are same, then it is called as symmetrical. Right? Is that clear? Now using this box plot, we are going to identify the outliers. For this, earlier, whatever the star marks you have kept now, that star marks are used for this one. Actually, the main question is this one. This is the highest star mark. Without this, there is no interview for data scientist. In the data science interview, they have to ask the word of outlier. Without this, there is no data science interview only. 100% they have to ask the question of outlier. In what way they are going to ask, that is different. But outlier word has to be used. Now, what is meant by outlier? Outlier means which is distant from the given data set. For example, in this class, we are having with respect to all the students, what is the age of the generally the students who are sitting in this class means age will be generally 22 to 25 or 28 something if you are experienced or something. If assume that there is one student who is of 50 years age and he is sitting in this class. Now, that particular person is called as an outlier for this class. For old age home, he is not an outlier. For this class, he is an outlier. Okay. For the given data set, he is an outlier. Generally, he is not an outlier or not. That is secondary. For the given data set, whichever is far away, that is called as outlier. Okay. If some person of, if for example, old age home and almost every person of 60 to 80 years are there. Every person is there. There one particular person is there of 22 years old. He is also sitting in the old age home. Then he is an outlier for that particular data set. Right? So for the given data set, which is far away or different, then it is called as an outlier. Okay, which is completely different. Right? Which is completely different, that is called as an outlier. That outlier can be left side, that outlier can be right side, any side. Okay, the outliers can be left side, the outliers can be right side. So that the how to identify the outliers means you can see the outliers by using the histogram. So one student is having like this. For example, using this outlier, okay, that I will tell later, that example. Okay, now you are having the outliers like this, where completely distant. Now how to identify the outliers means one by using the histogram you can identify. And the second one by using the box plot. So this is an outlier. For this data set, this is an outlier. For this data set, this is an outlier. Remaining values are from double digits are there means this is only a single digit is there. This is an outlier. Right? Now, you can identify the outliers by using the, in terms of, you can identify the outliers by using the histogram or by using the box plot. How to identify using the box plot? How to calculate the outlier data point means calculation is given by any value Q1 minus 1.5 into IQR is called as an outlier. Any value greater than Q3 plus 1.5 into IQR is called as an outlier. This is a right side outlier. This is a left side outlier. One is right side outlier and one is left side outlier. You know what is Q1? What is IQR? Q3 minus Q1, which is interquartile range. I have told you, right? Interquartile range. And Q3 minus Q1. Now for this data set, I have got the minimum value, Q1 value, Q3 value, and with respect to maximum value. In this data set, is there any outlier? First, you have to calculate IQR value. IQR is nothing but Q3 minus Q1. Q3 minus Q1, which is nothing but 36 minus 25, which is nothing but 11. First, you are going to calculate the IQR value. After calculating the IQR value, now what you are going to do? You are going to calculate this one. Q1 minus 1.5 into IQR, Q3 plus 1.5 into IQR. What is Q1? Q1 is 25 minus 1.5 into IQR, 11. And what is Q3? 36 plus 1.5 into 11. So you are going to calculate like this. 25 minus 1.5 into 11, 36 plus 1.5 into 11. If you calculate, any value less than 8.5 is called as an outlier. Any value greater than 52.5 is called as an outlier for this data set. In this data set, is there any outlier? 59 is available. That is called as an outlier for this data set. For this data set, this is an outlier. After remove, the outlier will be represented by a dot like this. Now, after removing this outlier, now what is the maximum value? 50. So now the box plot will be like this. The box plot will be represented like this. Now, the questions. First question is, what is outlier? First question is, what is outlier? Which is completely distant from the other data points, which is far away from the other data points is called as outlier, which is completely different. That is called as an outlier. This is question number 1. Question number 2. How to identify outliers? How to identify outliers? Either by using the box plot or by using the histogram. These two are called as identification of outliers. How histogram will represent the outliers? You can see in the histogram, the one of the data point will be somewhat far away, whereas remaining data points will be here, means one data point will be somewhat far away. So then it is called as outlier. Or from the box plot, how? And third question is calculation of outliers. How to calculate the outliers? How to calculate the outliers? How to calculate the outliers? That is any value less than Q1 minus 1.5 into IQR. Any value less than to this is considered as an outlier. Any value greater than Q3 plus 1.5 into IQR is called as an outlier. This is the calculation. Now, how you are going to check that one is using the box plot. Box plot will represent this one by showing some kind of dots. If left side outliers are available, miss left side, right side miss right side. One outlier miss 1, 2 miss 2, 3 miss 3, 4 miss 4. How many outliers are there? Those many dots will be there. In the interview, we'll ask how to identify outliers, means everyone will say the answer with box plot. Okay. In the further classes, you will be familiar with multiple times. Every day you will discuss with outliers and automatically you'll remember easily, sir, answer is by using box plot. But how box plot is calculating, means this is the backend formula. Within the box plot, this is the backend formula where Q1 minus 1.5 into IQR, Q3 plus 1.5 into IQR. Is that clear? Now, question is, okay, outliers identified. What happens if there is an outlier? Assume that in my class, one particular student is there who is 50 years age. Now, what happens? What is the problem for you if he is sitting in the class? What happens? If, for example, one LKG student is sitting in the class, what happens? So the thing is that 50 years person or this LKG student, if he is not synchronizing with the classmates, for them, we have to explain in a different way. We have to say with respect to, for LKG student, we have to go with a spoon, like very low level examples we have to go. Whereas for 50 years person, we have to explain with multiple examples. And he can't even remember whatever we have discussed 1 hour back or 2 hours back also. There may be a chance. Whereas with respect to the age of 22 to 25 or 26, they can remember more things in a short time, right? So now, if you are having an outlier in your data set, it is going to disturb the entire data set. It is going to disturb the entire data set. Sir, how it is going to disturb? Example. Now let us go with an example. Now, what is the effect of outliers? If it is more outliers are there, what happens? So now let us calculate this one. Okay. So let us take, we are having with each year in one area on July 1st, they have calculated the temperatures. The temperature in the year of 2015 is 26 degrees. In 2014 is 115 degrees. In 2013 is 20.5. In 2012, it is 31. And in 2011, it is minus 350, it seems. Minus 350 degrees centigrade, humans can live, or sensors will work. At least sensor will work first. No, it is some kind of technical error. Technical error or type error, whatever it is, some error. Due to some error, we have got the data like this, 2010 and 2009. Now, if you, this is an outlier. Everyone knows this is an outlier, very clear. But if you use this outlier and if you calculate the mean, what is the mean? Means minus 28. The average temperature in this location is minus 28. When minus 28 is there? None of the, due to one, we are concluding that this particular area, that average temperature is minus 28. How you can conclude like minus 28 in this area? Because 26, 15, 20, 31, 31 is the miss. How you can conclude with minus 28? So if you calculate the mean value is very much deviated. So due to the presence of outlier, the mean is getting deviated. If the mean is getting deviated, automatically variance also will be deviated, standard deviation will be deviated. All the statistic analysis will be disturbed. Due to the outliers, the entire statistical analysis will be disturbed. That is the reason we have to treat the outliers correctly. We have to treat them. If there is an outlier in your data set, we have to treat. Either treating in terms of multiple options are there. In that, one of the option is remove. But in real life, we should not remove. What we have to do with the outliers in my data set, if there are outliers, what we have to do? That we are going to see in the data cleaning class. That comes under data cleaning. Right? Now, for this data set, please calculate the mean with outlier. Include the outlier and calculate the mean. It is minus 28. If you remove the mean, if you remove this outlier, now calculate the mean. It is 25.66. With outlier, it is minus 28. After removing the outlier, it is just 25. Plus 25. Coming to the median with outlier, including the outlier, total 7 data points are there. This is the center value. Okay, 26 is the with outlier, median is this one. If you remove the outlier, the average of these two, center value is our average of these two, which is 28.25. Now, including the outlier, what is the mode? Means most repeated value, which is 31. If you remove the outlier also, most repeated value is 31. Whereas range, what is the maximum value? 31. What is the minimum value? Minus 350. Maximum minus max minus minimum, that is 31 minus of minus 350, which is 381. If you remove the outlier and if you calculate, what is the maximum value? 31. What is the minimum value? 15. Now range is only 16. So with outlier and without outlier, if you see the values, where the mean is heavily impacted, whereas median or mode are less impacted. They are less impacted, but whereas mean is heavily impacted, heavily affected with respect to the presence of outliers. The mean will be affected with outliers. If the mean is getting affected, means variance, standard deviation, everything will be affected. Now, what is the problem with outliers? Means the entire statistics analysis will be done the wrong way if you are having the outliers. If you are having outliers, the entire statistics will be done in a wrong way. Sir, can you explain with a real life example? Now, if you go with the example like Flipkart, in the month of October, big billion day sales will be there. In that particular month, what is the sales? Very high. In the month of September, in the month of July, or in month of May, the sales will be normal. Now, if you take now if you take the average, including the October sales, if you take the average, complete average, now how many months the Flipkart will have that average sales, you know? How many months it will satisfy the average sales, you know? Just only 2 months it will satisfy the average sales. Remaining 10 months, it is below average sales only. If you include the big billion day sales. If you remove the big billion day sales and if you calculate the average sale, you'll have with respect to almost 9 months will satisfy the above average. Right? So whenever you are going to do the forecasting or prediction, we have to take care with respect to the outliers because the outliers are going to impact heavily. Let me explain with a very, very, very simple example. Now, what is the universities or colleges, engineering colleges or universities like SRM or VIT, all these universities will give in the campus placements with average package. Now assume there total 10 students only are there. Assume 10 students are there. Student number 1 has got 3 lakhs. First student has got 3 lakhs package. Second student, third student, fourth student, fifth student. 5 students has got 3 lakhs package. 4 students has got with 4 lakhs package. 1 student has got 20 lakhs package. What is the average? In this case, can you calculate the average? 15 plus 16, 31 plus 20, 51, 5.1 lakhs is the average package. How many students satisfy the average package? By showing this one student, they are highlighting the average package of 5.1. Average package, never ask the what is the average package, ask the median package. Median package will give you the exact results, more close results. But these universities will cheat by using the average packages. Assume that in SRM University, let us take example of SRM University. Okay, example only, pure example. If anyone is there from SRM, no, right? I'm only the person, right? Okay, then I'm only the person. I worked as in SRM as I'm not student. I'm worked as the SRM placement in the placement team. So I know what are the things was happen inside and how the students will be get placed and what are the gimmicks they are going to play before the place. Everything I know. Okay, let us keep this one aside. Now in the SRM University, we are having total 100 students are there. Okay, take an example of 100 students, out of which 90 students has got 3 lakhs package or 3.5 lakhs package. 5 students has got or 9 students has got with 6 lakhs package. 1 student has got with 1 CR package. What is the average package? 90 into 3, which is nothing but 2 lakhs 70 lakhs, 270 lakhs. 9 into 6, which is nothing but 54 lakhs. 1 CR means 1000 lakhs, which if you calculate 424 divided by 100, which is nothing but not 424, na 324. 1 CR is 100 lakhs only, na 100 lakhs only. 4 and sorry 12, 12 only. 424. 424 lakhs only. Divide by 100. You have to do with respect to divide by 100. Now how much? Now you got with respect to 4.24 lakhs. Now out of 4.424 lakhs, 90 students are not satisfied. 90% of the students are not below average package only, you know. 90% of the students. If you see with the average package, generally what is meant by average package? Center value. 50% of the students only should be below to that. 50% students should be above to that. Here 90% of the students are below to that. Now if you remove this one, now calculate once again. Now you will get with respect to 324 divided by 99. Now 99 students only, na? So 324 divided by 99, which is approximately 3.3. Right? So 3.3 or 3.2, something like this. Now, one particular value has influenced the entire mean and the entire statistics. So that is the effect of outliers. So that is the reason in the real life, we have to treat the outliers. Without treating the outliers, we can't proceed with the statistical analysis. So outliers are one of the most important part, and we have to clean the outliers. That comes under data cleaning session in the further class. So you have to remember the outliers concept. Don't forget, because again, we are going to use in the further class, right? So that is with respect to outliers.